What we're going to do today, I'm going to use some of those bricks that we were given from being hit by that ton of bricks from the coronavirus, and I'm going to use those bricks again. Now, we're going to use our imaginations today. There are holes in these bricks, but what we're going to do is we're going to imagine that there are no holes in these bricks. These are solid bricks all the way through, completely made of clay. So there are no holes in here. That's going to be our assumption when we do our surface area and volume. Okay, so that's for all intents and purposes. These are solid bricks for our activity that we're going to do today. Okay, what I'm going to show you guys today is taking a rectangular prism and changing one of its measurements or one of its dimensions, what we call an attribute. So if we change one of the measurements of a rectangular prism, how does that affect its surface area and volume? Well, let's take a look. What I have here is a brick that I pre-measured, and I'm going to call this the length. It had a length of 7, it had a width of 3, and a height of 2. So, I've written those measurements down here for you. I've already calculated the surface area and the volume for you, as you can see. Now, what happens if I change one of these dimensions or measurements? Well, let's say what I do, I'm going to take another brick and I'm going to change the height of this structure. So we started with one brick. I'm going to change its height and only its height. And specifically, I changed it by doubling it. So basically, I took the original height I had and multiplied it by 2 because I have double the height now. I still have the same length and I still have the same width. I just doubled my height. It's the only change I made. Now, how would that look like mathematically over here? Well, my length stayed the same, 7. My width stayed the same, 3. And then my height doubled to 4. Now, what that would do to our surface area is give us a surface area of 122. It's a little windy out here. And then what it would do to our volume is change it to an 84. So now we have 84 cubic inches as our volume. Now, if you look closely, they both increase. So going from 82 to 122 is an increase, and going from 42 to 84 is obviously an increase. However, there's a specific kind of increase for the volume. How would 84 and 42 relate to each other? Well, 42 doubled is also 84. And remember, I doubled the height and I left the other two measurements the same. Okay, so here would be another example. Example number 2. I'm going to, this time, instead of increasing the height, I'm going to take the height back to its original, which is 2 inches. I'm going to increase the length. So if I place another brick here, I've just doubled my length. But I kept my width the same, and I kept my height the same. My height's still the same, my width's still the same. I doubled my length of my structure. Now, what does that look like mathematically? Well, I originally started with this. I doubled or multiplied my 7 by 2. Oh, that's incorrect. My 7 by 2 and got 14. I kept my other measurements the same. Now, what I'll do is with our surface area, it will give us 152, which, yes, is obviously an increase. But with our volume, we end up with 84 again. So I doubled one of the measurements, the length, and I also got double the volume. Okay, so it also works in reverse when we're changing attributes. So let's say we started with a structure that was a little bit larger and we want to reduce it in size. So what I've done, I've set up another third example here. Here's my structure. Now I have a length. I'm starting with a length of 14, a width of 3, and a height of 6. Now what I'm going to do is, and I've already written the numbers down for you, I am going to change its length to 7, which would be half of what it is now. So if I change its length to 7, I have to move this block out. But it also means I have to move all these blocks out. All 3 of these blocks have to be removed. Now, I have 7 again. I did not change the width. The width stayed the same, 3, and the height still stayed the same, 6. So the only thing I changed was the length. I went from 14 down to 7. Now, if we look at the numbers, this here tells me that I started with 14 and I went to 7. So basically, I cut it in half. We could say I divided by 2. I left the other measurements the same. What happened to the volume going from 252 down to 126? Well, if you divide 252 by the same amount, 2, you get 126. So basically what I'm trying to demonstrate to you is if you divide one of the measurements or dimensions by a particular amount, it's going to do the same to the volume. So our volume was divided by 2. Now, that's using division, but you can also use multiplication. So we had 14, and I went down to 7. You could also multiply by 1/2, since these are reciprocals of each other, or opposites. Which means we could also take 252 and multiply by 1/2, and we will also get 126. Oops. So again, just to kind of review what I just said, anytime that you change one measurement in a rectangular prism, it will also affect the volume by the same amount. So if you double one of the measurements, it will double the volume. If you take half of a measurement, it will reduce the volume by 1/2. Now, to kind of give you an idea of why the surface area does increase, but not necessarily like the volume does, if I were to place another brick on top of the first brick I had, well, I just covered up part of the surface area, so this part is no longer the surface area any longer. It's just replaced by this surface area. Now, it did increase the surface area here, and it did increase the amount of surface area here and on all of these sides, but the tops and the bottoms were not increased. I've shown you what happens when you change the measurement of one of the dimensions and how it affects the surface area and volume, particularly the volume. Now, what happens if you change all of the dimensions or all of the measurements by the same amount? For example, let's take my one brick I started with. What if I were to, say, double its height? Well, I would have to place one brick on top of it. Now I've doubled its height. I also want to double its length. Well, I would have to place a brick here so I can say, okay, now the length is doubled. But I would also have to place another brick here to keep the height the same of the entire structure. And then let's say, okay, well, I need to now double the width. Well, I need to make it twice as wide. So I just made it twice as wide, twice as long, and twice as high now. So I just took this structure with one brick, and now I end up with 8 bricks. Now, what does that look like mathematically? Well, here's what we had. I had originally a length of 7, 3, and 2 with one brick. Well, then I just multiplied each of the dimensions by 2. I increased each by 2. I doubled them. So I ended up with a 14 by 6 by 4. The surface area is 328 and the volume is 336. I'm not so much concerned about this. This increased, yes, but the volume increased. And how does 336 relate to 42? Well, if you take 336 and divide it by 42, you get 8. So basically what that says is I just increased the entire volume of this structure by 8 times the amount. So I have 8 times the amount of volume that I started with my original 1 brick. I increased each of the length, the width, and the height by 2. So I increased the length by 2, the width by 2, and the height by 2. If I multiply 2 times 2 times 2, I get 8. And that's what happens when you increase all the dimensions by the same amount. To review what we've done here today, we've changed one of the measurements by a particular amount in a rectangular prism. And what happens is the volume changes by that same amount using either multiplication or division. So if we double one of the figures, one of the measurements, it will double the volume. If we reduce the volume, or if we reduce one of the measurements by, say, 1/3, it will reduce the volume by 1/3. Okay, one last thing. What is red and bad for your teeth? A brick.